Hey guys, welcome to lesson 312, day 2. We are going to continue with rewriting expressions and determining whether expressions are equivalent. So for our first problem here, we have two functions and we are going to need our calculator to figure out what the table looks like so that we can get our graphs and tables going. I have already typed in that first function for us, so let's take a look at what our table shows us. We'll look at the graph first. Alright, so if you press second and then graph, we'll get our table. So we see here that our table has these values on it. So these are the ones we're going to write down. Because our table, we started at 0 and went to 5, we'll follow our 0 and go to 5. So we'll go 5, 0, -3, -4, that type of thing. So 5, 0, -3, -4, -3, and 0. Okay, that is our first table. Now we can go ahead and go to our y equals and graph the second function, which is going to be this guy right over here. I'm going to remove the first one for now. Actually, I'll leave that one. So we have x plus 1 times x plus 5. Alright, so now we'll go ahead and go to the table. And right off the bat, we can notice whether or not these tables are the same because they are right next to each other. This red column is g of x, and the blue column is f of x. So the g of x table is obviously very different from the f of x table, which does tell us that our functions are definitely not equivalent. So let's go ahead and get down that table here. We have 5, 12, 21, 32, 45, and 60. All right. So now that we have all of our table values, we're going to go ahead and plot them. So for f of x, we have 0, 5. We'll go somewhere over here. This is going to be very approximate. Don't worry about it being like extremely accurate. So -2, -3 is going to be here somewhere. I'm going to go ahead and pause the recording so I can plot these and I don't use up too much recording time. Alright, I have finished my graphs and we can see that not only were my tables different, but my graphs were also different, and you can see that on the calculator as well if we go ahead and let this thing graph that. And so we can therefore conclude that they are not equivalent. Okay, so using the generic rectangles to multiply out g of x is just saying that we need to take these factors and put them around our rectangles. So x plus 1 and x plus 5, we will put 1 here, and we'll put 1 here. Okay, again, it doesn't matter if we had switched those. All that matters is that we multiply correctly. So x times x is x squared, x times 1 is 1x, x times 5 is 5x, and 5 times 1 is 5. So we end up finding these like terms, so don't forget to combine those, and that's going to add up to give us 6x. So finally, we know that our sum would be x squared plus 6x plus 5. Oop. Gosh darn. Alrighty. Okay, and this is x squared plus 6x plus 5, whereas our original was x squared minus 6x plus 5. So we also know this way that they are not equivalent. All right. So we are also going to be doing some of the 2x3 stuff on the quiz as well. Now, if I ask you to multiply this out, you need to be able to recognize that you're going to need to set up that 2x3 box. Okay, because one of those parentheses has 2 terms and one of them has 3. So obviously, if this one has 3 terms, we're going to need to put that on the side of the box that allows for 3 terms. And then the other one can go on the side. Okay, negative 4x minus 3. So let's go ahead and multiply this stuff out. Negative 4x times 3x squared is going to be negative 12x to the third. Okay, and it's to the third because x squared times another x, that's a total of 3x is being multiplied. Negative 4x times 4x is negative 16x squared. Negative 4x times 7 is negative 28x. Negative 3 times 3x squared is negative 9x squared. Negative 3 times 4x is negative 12x. Negative 3 times 7 is negative 21. Okay, and now, before we go ahead and sum everything up, we do want to acknowledge that we have some like terms to deal with. For example, these two, when you add them together, you end up with negative 25x squared. And we also can add the two x terms. And those are going to give us negative 12 plus negative 28. That's going to give us a negative 40x when we add those together. So our final sum that we're going to get here when we add everything together will be negative 12x cubed minus 25x squared minus 40x, and then minus 21. And again, I'm just adding everything in the box. Okay, and that is our sum. All right, so now we're writing the sum as a product on the other hand. This is when we have to factor with box and diamond. All right, we got our box here, got our diamond. So our first term, as usual, goes in the top left. Third term goes in the bottom right. And now we can fill in the diamond. We know that first times third term multiplied gives us the top. So this is going to be 75x squared up here. And then middle term goes in the bottom. All right, so now that we've done that, we can go ahead and play the game. We have to ask ourselves, okay, well, what two numbers are going to multiply to make 75 and also add to make negative 20? Eventually, we would stumble upon the discovery that negative 15 and negative 5 are going to make that happen. If we multiplied those, we would get 75. If we added, we'd get negative 20. So we fill in the rest of our boxes. And now that the hard part is over, we can just go ahead and fill out the outside. What times what equals 3x squared? Well, we know we need an x and an x. However, we also need that 3. Now here's the thing. If you tried to put it here, we wouldn't be able to find a number for this spot because we can't multiply 3 by anything to get negative 5. However, if we put it here, we can multiply 3 by something to get negative 15, which would be a negative 5. So it works there, and which means we have to put it on the top. Okay, in this one, we would be a negative 5 because that's how you would get negative 5x from x. So our product or factored form would be 3x minus 5 and then x minus 5. And you're done with that. All right, so the last portion here is for some review. It's some older stuff that we're still going to be responsible for doing. So I thought I'd bring that up as well. Now, when we are rewriting in graphing form, this means we need to complete the square. Okay, so this means that we're going to do the box. This is where we have to split the middle term. Kind of an ugly box, but we'll be all right. So we have x squared as our first term, so it's going to go in the top left. And then this is where we have to split our middle term, right? We take this guy and we have to divide it by 2. We get 4x. So that goes here and here. Always goes in the 2 diagonal boxes. Okay, once that's done, we can fill out the outside. What times what equals x squared? That would be x and x. and then to get the 4x, we need a 4. So now that we have those two numbers, we can multiply those to get this box, which will be 16. And that means that our answer is going to be x plus 4 squared, and I got that from this outside portion. And then we need to be mindful of the fact that here we have a 16, and what we wanted was a 15. Okay, so to get from 16 to 15, we have to subtract 1. To get from 16 to 15, we had to subtract 1. So we'll put that minus 1 on the end there, and we are done. Okay, and with this being the vertex form or graphing form, both are the same thing, we can say that the vertex, which is opposite of h comma k, that means for us, we're going to take -4 and -1. That's going to be the vertex. You could always check that by graphing it too. All right, so factored form. Now we just get to factor this, and same exact process that we did up here. So I'm not going to go through this one too slowly. So I have a 15-minute recording limit on this thing, so I gotta pick wisely. All right, so first term always goes in the first left box, top left box I mean. Third term goes down here. And then we can go ahead and do the box and diamond, or now we're on the diamond part, I suppose. So in the top portion, we'll get a 15x squared, and the bottom we'll get an 8x. And the two numbers that multiply to 15 and add to 8 are going to be 5 and 3. So these are the ones we'll use. Fill in the rest of our boxes. And now we can find the outside. X and X. We'll put a 3 here, and we'll put a 5 here. Now here's the deal. We end up with x plus 3 and x plus 5. Okay, this is what our f of x is going to equal in factored form. But if we want the x-intercepts, then we can always just solve this. Okay. X would equal -3 and x would equal -5 if we were to solve this by setting equal to 0. So if we set it equal to 0 and solve it and got these numbers, that tells us that the x-intercepts are -3, 0 and -5, 0. And we just use these numbers, the -3 and the -5. All right, now we have to do y-intercept, domain, and range. So here's the deal. It might be helpful if we actually graphed this first. So let's go ahead and get our calculator and graph it. I'm going to go ahead and graph this and pause the recording while I do that. All right, I have typed it in here and I've graphed it. So here's my graph. Remember to find the y-intercept. If it's not obvious on the picture, you can always go to the table and see where the x value is 0. So if we go to our table here, second table, we can find that where x is 0, and let me pull up the big screen here. Where x is 0, we have a y value of 15. So this right here is our y-intercept. So that's that. And for the domain, remember how this works, right? You look at the graph and you say, okay, well, the farthest left this is going to go is going to be towards -infinity because it goes on forever in the left direction. And it also goes towards the right forever too. So our domain is going to be -infinity to infinity. Remember that the domain of parabolas is pretty much always going to be -infinity to infinity because of just the nature of how the graph looks. Unless if there's like funky dots in the middle. And then for range, the lowest it's going to go is a y value of -1, and then it goes up forever. So the low part of the range is going to be, the low part of the range is going to be -1, and it's going to go all the way towards infinity. Just remember that you need a bracket around -1 because it's a valid part of the graph, and then the infinity always gets a parenthesis. Okay, and that is all for today. Good luck on your quiz.